Hello friends, I welcome you to my YouTube channel MacPM. So in today's video we have to solve this question. A beam has a cross section as shown in figure. This is a T cross section which is symmetrical. If the shear symmetrical about y-axis only, not about x-axis. If the shear force acting on this is 25 kN, draw the shear stress distribution diagram across the depth. So we have to draw the shear stress diagram, distribution diagram. So we have to find shear stress at extreme points, at this point and this point, then at flange and at the web, then at the neutral axis and at the point where it is maximum. So for this we have formula: shear stress is equal to F upon Bi into A into y bar, where F is shear force which is already given 25 kN, B is width of this section at section which we are considering, width at that point, then width, then I is moment of inertia of this cross section which we have to calculate, and A is the area. Suppose we are considering this cross section, suppose we are drawing enlarged T section, so then we can visualize easily. Then if we are selecting this cross section AA, then A is area above this section, this is A, and y bar is distance of the neutral axis of this section, which is half distance from this portion, so half of this, so this from the center neutral axis of the whole cross section, this is y bar. Okay, so first of all we have to find the centroid of this cross section so that we can calculate the moment of inertia of this cross section. So centroid will be, we know that because it is symmetrical about y-axis, so we don't have to find x coordinates, only y coordinate. So y bar is equal to, y dash is equal to centroid will be, suppose we are considering this point as origin, then a1 y1 plus a2 y2 divided by a1 plus a2. Okay, so a1 is, this is, suppose this is 1, this is 2, so this area is 120 into this width is 12 plus a2 is, y1 is from here, the centroid of this will be, suppose this is like this, centroid will be at half of this depth, so this is 12 centimeters, so it will be 12 by 2 or 6. a1, this is a1, this is y1 plus a2 is area of this, so this total is 120. So if we deduct 12 from it, then it will become 188 from here to here. So 188 into width is 12, this is given, into y1 is, so it will be at half of this side, so 188 by 2 plus this distance 12, because see we have to calculate the distance of centroid of this section from the origin. So from origin this is 12, this one is 12 plus this one is 188 by 2. Okay, now a1 y1 a1 plus a2, a1 we have already calculated, 120 into 12 plus 188 into 12. Sorry, I have committed a mistake here, this is only 120, so if we minus 12 from it, it will become 108, so it is 108 and it is 108, this is 108. Okay, so if you calculate this value, then you will get 34.42 mm. So this is centroid of this T section from this point, so this distance will become 34 34.42. So remaining it will become 120 minus 34.42 will become, this is 85.58. Now we have to calculate the moment of inertia of this section. So moment of inertia will be moment of inertia of this flange section about this centroid, then moment of inertia of this section about this centroid. So moment of inertia is bhq by 12. So b is for this section 1 is 120 into height is 12 divided by 12 plus bhq by 12 plus area into distance square. So area is 120 into 12 into distance is distance from 34.42 minus distance of centroid of this flange is 12 by 2, 6 square plus moment of inertia of this web section will be bhq by 12. So b is 12 into hq, h is 108. So 108 cube by 12 plus area is 12 into 108 into distance of centroid of this from this centroid. So this we have to calculate centroid of this portion minus from distance of centroid of whole section. So it will become 34.42 minus 108 divided by 2 to the square. Sorry, like that. So if you will calculate this from the calculator, then you will get 2936930 mm to the power 4. Now we have to calculate the shear stress at various fibers of this T section. So formula for shear stress is Q is equal to F upon BI AY bar. So you can see that for top fiber area above this is 0. So this AY will become 0. So Q at top and bottom will become 0. Okay. Now we have to calculate at bottom of this flange. So it is like this. So we have to calculate at this point. So area above this will become this one, this whole area, and y bar will become distance of neutral axis from this neutral axis of this section. This will become y bar. So it will become F is already given 25 kilonewton, 25 into 1000 Newton divided by B is this, which is given 120, into I is already we have calculated, which is I we have already calculated, which is 2936930 mm to the power 4 into AY bar. So area is 120, this is 120, and this is 12. 120 into 12 into y bar is this 34.42 minus half of this 6. So it will become 34.42 minus 6. It will become, if we will calculate this, then we will get 2.90 Newton per mm square. So this is shear stress at this point. If you want to calculate at same point for the web portion, for this portion, then only difference will be Q at web will be Q at flange this is, sorry, Q flange this is, and Q at web will be same formula, F upon BI into AY bar. So F is 25 kilonewton divided by B will become 12 only, because width of the web is 12 mm. So this will become 12 into 2936930 into area will be same, 120 into 12 and 34.42 minus 6, everything is same. So if you will calculate this, then you will get 29.0 Newton per mm square. If you want to calculate in shortcut method, then you can already calculate by 2.90 at flange into width of the flange, means B flange upon B this web. So it will become 2.90 into this is 120 and this is 12. So it is 120 divided by 12. So it will become 29.0 Newton per mm square. Now if we have to calculate at another point which is important for us, which is neutral axis. So if you want to calculate the neutral axis, then we can calculate area into distance AY portion for either for this section or for this section. So for top section, if you will consider, then it is two areas. So we have to calculate it A1Y1 plus A2Y2. So better we have to calculate only one A3Y3 for the bottom section. So if you will calculate, then it will be Q neutral axis will be same F upon BI into AY. Okay, so F is already given 25 kilonewton, B is 12 and I is we have already calculated, which is 2936930 into A into Y we have to calculate. So let's see what is the value of AY. So area is area of this, so it is area will be this width is 12 into height of this is 120 minus 34.42. So if you will calculate, you will get 1026.96 mm square, and we have to calculate y also. So what will be y bar? Y bar will be distance of neutral axis from centroid of this, which will become 120 minus 34.42. This portion, it is height of this portion, divided by 2, it will be centroid of this portion, minus from this point, so it will be divided by 2 will be distance, so it will become 42.79 mm. So we will put all the values in formula. So we will get Q is equal to, we have already found this value, and we will put this value also. So it will become 25,000 divided by 12 into 2936930 into area is 1026.96 into distance is 42.79. So if you will calculate this, then you will get 31.17 Newton mm square. So now we have found the shear stress at all the important points, so we can now draw the diagram of the shear stress distribution across the section. So this was our T section, and this portion we have calculated top and bottom flanges portions are shear stress is 0. So here also it is 0. At this point we have calculated 2.9, so it will be 2.9, and at this point we have calculated 29 in the same line, so it is 29, and at neutral axis we have calculated 31.17 and here it is 0. So we will add these points. So this is the shear stress distribution across T section. I hope you understand how to calculate the shear stress and how to draw this diagram.